Okay, so today let's talk about geometric sequences and how to put them into a formula where you can just generate the nth term automatically. Okay, so what you want to do is start with whatever the first term is and multiply it times the ratio to the n minus 1 power. So it's very much like putting the arithmetic ones in there, you know, of course, except it works with the ratio instead of the common difference. Okay, so in this case, if it makes more sense to you in any particular problem, you could go back to A0. Most of these problems, you're going to be fine using this. So that was just kind of an option last time to just, like with arithmetic sequences, to kind of tie it in better with what you knew about lines, and this obviously you could kind of tie it in with what you know about exponential functions, and it's a little easier to directly tie it in with this formula, but anyway, this formula is going to get you through these problems. So there's only a couple problems that I'm giving on this assignment just to get familiar with it more than anything else. Okay, so let's go ahead and start with this first problem. Okay, so let's say Callie starts working and she's earning $30,000 a year. And let's say she gets a raise of 5% each year. So how can we represent this into a geometric sequence? Okay, so we're going to call this A1, her first year. Okay, so then in this case, it's going to be A sub n. Here, I'm going to write the general formula first. Okay, so it's just going to be 30,000, okay? And then a raise of 5% each year, it's going to be a multiplication by 1.05. It's just going to be times, it's up to the n minus 1 power there, okay? So hopefully you see how that works out. And if you plug in, let's say you plug in n equals 1, right? Then you're going to get 0 for the exponent, so you get the 30,000 back. So it checks for the first one. Okay, so obviously you could use that formula to see what she would actually get. Let's say her 8th year of working, you want to know what she would be earning, okay? So you would just put, 8 for the n, and then do 30,000, okay? And then you do 1.05, of course, you plug in, 8 minus 1. So it'd be 30,000 times 1.05, and of course it'd be to the 7th power. And I'll let you finish that one off. Okay, so the next problem is one like this. Okay, let's say you're given the first term and you're given the ratio. Hopefully this is a no-brainer as well. Okay, so what you want to do is just plug it in. Okay, so it's going to be A sub n is equal to A1 times r to the n minus 1. Okay, so if I plug in, I'm just going to plug in my 125. Okay, my r in this case is 1/5. Okay, so this is going to be a decreasing sequence, you can probably tell. And that's going to be to the n minus 1. Okay, so that's going to be my formula for this, and of course then I could use it to calculate anything further in the formula. So let's say I wanted to calculate, say, the fourth term of this. Okay, so it'd be 125 and then times 1/5, and it'd be to the 4 minus 1 power. So it'd be 125 times 1/5 cubed. Of course, you can probably see that in this case it's kind of weird because that's 5 cubed and that's 1/5 cubed, so it's going to be kind of weird because this one turns out to be 1. But of course I can build it and check it. A lot of these are checkable other ways. So let's see how it works if I build it out the long way. Okay, so A1, 125, right? This is all to check. Multiplier is 1/5, so it's going to be 25, right? Then 5, then 1. So you can see A1, A2, A3, A4. It really is 1. So these are pretty easy to work with. You really shouldn't have too much trouble with this. Okay, well, let's just do one more. So let's do one like this one, okay, where you have to kind of look at the geometric sequence and realize what it's doing. So let's say we have this one, 0.2, then 0.02, 0.002, and etc. This one obviously could go on forever. Of course, you added them up. Hopefully you realize, you get something interesting there, get a repeating decimal. We'll do that later. Okay, so this would be your A1, okay? What am I multiplying by to get from term to term to term? Hopefully you see I'm just multiplying by 1/10, okay? So you could use the formula again for this. A sub n is a1 times r to the n minus 1, okay? So go ahead and plug in your a1, that's 0.2. Your ratio is going to be 1/10, or if you want to use decimals, you could write it like that, to the n minus 1, and that's going to be your a sub n. Okay, so again, you could work with this and get other terms if you needed to plug stuff in. Okay, good luck.